Focus in Directrix with the vertex away from the origin. So first, I want to talk about the equations at the top. So if a parabola opens up or down, this is the equation that is used to write the formula for the quadratic function. Notice it's pretty much the same as the other one. However, now we have h and k because h and k are no longer 0. So h and k still come from the vertex just like they did previously. Similarly, if we have a parabola that opens right or left, we have this formula here. And notice that h and k are now flipped. K is inside the parentheses and h is on the outside. But the vertex coordinate is still h comma k. So be careful and make sure you're pulling the right value for the x and the y of the vertex. The value of p is still the distance of the focus from the vertex. That's still the value of p on both of them, no matter what. Or you could also think of it as the distance from the directrix to the vertex as well. So let's practice using these formulas just to find the vertex. So on the first one, we have the y equals 1/8 x minus 6 squared plus 2. So since it's in the format of y equals, that means this is my h and this is my k. But remember that anything inside the parentheses will lie. Inside the parentheses is going to change signs. So the h is actually the opposite sign from the equation to the coordinate. So when we write this coordinate, the vertex is h comma k. So the h is actually a positive 6 and the k is a positive 2. On the second example, we have an x equals. And so what that means now is that means this negative 3 is actually the k and this 6 is actually the h. And since the k is now the one inside the parentheses, the k is the one that is the opposite sign from the equation. When you write your vertex, though, your vertex is still in the form of h comma k. So h is that 6 on the outside, and k is actually a positive 3. So for example 1, it says, write the equation of the parabola that opens down, has a vertex at 3, 1, that is 5 units from the focus. So the biggest thing with these is make a sketch. If you can draw the picture, it's going to be easy to find all of your values. So the first thing that I know about this parabola is that it opens down. So right now, that's not extremely helpful. I do know that the vertex is at 3, 1. So I'm going to plot that. 1, 2, 3, 1. So here is the vertex. And so I'm going to list that on the side. I like to list everything that I know about this quadratic on the side. And I also know that that vertex is 5 units away from the focus. But if all I have is this information, that doesn't help a lot because this could be 5 units above the vertex or it could be 5 units below the vertex. So we have to use the fact that the parabola opens down to help us. So this is kind of what my parabola should look like, something like this. And so since the parabola opens down, I also know that this here is the axis of symmetry. A vertical axis of symmetry because that's the line that cuts it in half. Now that I have the basic idea of the function, I can talk about the focus. So now that I know that it opens down and I know that the vertex is 5 units from the focus, I know that the focus has to be 5 units below the vertex. And the reason it's below the vertex is because the focus is always inside your parabola. The directrix is on the outside. So I need to plot this coordinate 5 units down. So 1 unit, 2 units, 3 units, 4 units, 5 units away from the vertex. So we can make sure that was right. So start at the vertex here and move 5 units down. So the coordinate of my focus isn't entirely too important, but let's write it out anyway. So the x value of 3 and a y value of negative 4. Now, last but not least, I can start to figure out my equation. So because I'm opening down, my parabola is going to follow the y equals 1 over 4p times x minus h squared plus k formula. The last thing I need, all I need for this formula is p, h, and k. We already have h and k from our vertex. That was given to us. The last value that I need is the value of p. And so remember from the previous lesson that the p-value is the distance from the vertex to the focus. And so if I count, the distance from my vertex to my focus is 1, 2, 3, 4, 5. Now it's actually going to be a -5, and the reason why it's negative is because the parabola opens downward. Upside down means a negative value of p. Now I have everything that I need. So we're going to go substitute our values. So y equals 1 over 4 times p is a -5, parenthesis, x minus h, which is a 3, squared, plus k, which is a +1. And the only thing that we need to simplify is this here, 4 times p. We can leave this in vertex form. That's not a big deal. I just need to simplify the 4 times -5, which will simplify into a -1 over 20, x minus 3 squared plus 1. There's the equation of this parabola. So for example 2, we're given different things. So write the equation of the parabola that has a focus at 2, 3, and a directrix at x equals 4. So sketching is always a big thing. If you can find the picture, you can do okay. So focus at 2, 3. So 2, 3. So here would be my focus. And the directrix is at x equals 4. Well, x equals means that this is going to be a vertical line. So 1, 2, 3, 4. So here would be my directrix. And I'm going to move my little F label. Now, the big thing is this is all I'm given about this parabola. Well, in order to use either format, I need the vertex. So that's my step 2, is I need to determine the vertex. And the way we determine the vertex is it's the coordinate that's right in the middle of the focus and the directrix. So we're going to do some counting. The distance from this focus to this directrix. So this distance is 1, 2. So that means directly in the middle, if I take 2 and divide it by 2, I end up with 1. So that means that my vertex is 1 away from the focus and 1 away from the directrix. So if I go 1 unit inside, this will be my vertex. And we also know that the vertex is not up here, the vertex is not down at the bottom, because the focus and the vertex are always either at the same height or the same level. They're never diagonal from each other. And so now that I have this, I can even get one more thing. I know that it has to open to the left. It has to go like this. And the reason is because remember that the focus is always inside my parabola. If I were to draw my parabola this way, my focus is not inside. And so it's the wrong direction. The focus is always inside the parabola, so that's why it opens to the left. Now I have plenty of information to figure out my equation. So because it's opening left, we're going to use the x equals 1 over 4p times y minus k squared plus h format. And again, all I need is the value of p, k, and h. Well, h and k I already have. We already found the vertex, and here's the vertex. So let's write out the coordinates of my vertex. So a 3, 3. So h is a 3, k is also a 3. For the value of p, well, we kind of already found that out. I know that the focus and the vertex are 1 away from each other. But because the parabola is facing left, my p is actually going to be a -1. So it's negative because the parabola opens left. Now that I have my values, we can substitute them in. So x equals 1 over 4 times the p value of -1. Parenthesis, y minus k, which is actually this 3 is the k, squared, plus h, which is this 3 here. So they are the same number, but they are 2 different 3's. And all we need to clean up is the bottom. So x equals -1 over 4, because 4 times -1 makes -4, times y minus 3 squared plus 3. So the basic idea is this. The basic steps is find out what you know about your parabola and sketch what you know. If you're given the vertex, great. If you're not given the vertex, then you need to find the vertex. And then substitute the values of h, k, and p. Let's do one more. And this is still giving us something different, so I do want to run through this together. So write the equation of the parabola with an axis of symmetry at x equals 2 and has the focus 4 units above the directrix, that is y equals -6. If you want to pause the video, try this on your own, and then come back and see if you did it correctly. So first we're going to sketch what we know. I know that it has an axis of symmetry at x equals 2. So x equals is a vertical line at x of 2. So 1, 2. So here is my axis of symmetry. And I'm definitely going to label because I also have a directrix, which is also a line. So the directrix is y equals, and that's horizontal. So it's a horizontal line at y equals -6. So this would be my directrix. The last thing that it gave me was that the focus was 4 units above the directrix. Now, the reason why we need the axis of symmetry is this focus has to lie on the axis of symmetry. So if we were not given the axis of symmetry, my focus could have been here or here or here or here. But because they gave me the axis of symmetry, I know that it's on the red line 4 units above my directrix. So from here to here is 4 units. This is my focus. Now that's fine and dandy, but I need my vertex. You have to have your vertex to write this equation. So that's what step 2 is. I've written what I can. Now let's find the vertex since I wasn't given the vertex. So again, middle of the focus and the directrix. So I know that from here to here is 4 units. So half of 4 is 2. So that means my vertex is going to be 2 below the focus and 2 above the directrix. It's got to be in the middle of them. So this is your vertex. And then the final piece that I now know is that the parabola is opening upwards because it has to go around the focus. So all this information has helped me see we're going to use y equals 1 over 4p times x minus h squared plus k. And again, all we need to find are the values of p, h, and k. So h and k come from our vertex. So the coordinate of our vertex is this point here. So an x value of 2 and a y value of -1, 2, 3, 4. So h is a 2 and k is -4. And then the value of p is the distance from the focus to the vertex, which we already said was 2. And now it's a positive 2 this time because it's a parabola that opens up. So when we plug in all of our numbers, we have y equals 1 over 4 times the p value of 2 times x minus h, which is a 2, plus k, which is a -4. And so your final answer for your equation is 1 over 8 times x minus 2 squared minus 4. For example 4 and 5, we're going to work backwards. We're going to identify the vertex, focus, directrix, and axis of symmetry from the equation. So now we're working in the opposite direction. So first, I notice that this is y equals. So I know that the layout had to come from y equals 1 over 4p times x minus h squared plus k. Well, this is basically vertex form. So I can very easily find the vertex from here. So I'm going to list that on the right. So my vertex is, remember that this is always h comma k. And if I follow my layout, this is the h and this is the k. So my h is -2 because it's inside parentheses, so it's opposite. And my k is a +1. And I'm going to go ahead and make a sketch as I go, because again, the sketch is going to help us with this process. So the vertex is at -2, 1. So here is my vertex. Now, let's think about opening direction, because that is important to find the axis of symmetry, because right now I could open up, I could open right, I could open down, or I could open left. Those are all parabolas. I don't know which one it is. Well, that's going to give us the a value and also how the equation is written. So because it is a y equals, that means it's either opening up or down. And because this is a negative in the front, that means it's going to open down. So the y equals tells me up or down, and then the positive or negative in the front tells me whether it's up or down specifically. And now that I know that it opens down, I can draw on that axis of symmetry. So the axis of symmetry is vertical for this guy. So a vertical axis of symmetry is x equals. And since it's x equals, the x of the vertex is -2. If it had been horizontal, that means this would be your axis of symmetry, which changes the equation. Now it's a y equals. So you have to be careful on whether or not it opens up, down, or left, right. The other thing I needed, so I got the vertex, I got the axis of symmetry. The last two that it asked me to find was the focus and the directrix. Well, both of those, I need to know the value of P in order to find them. So basically, finding the value of P. So finding P. Here's the mathematical way to do it. This number here, and this number here are the same number. So I'm going to take what I have given to me, negative 1 over 4, and I'm going to put that equal to 1 over 4p. And I'm going to solve this for p. So what we have is a proportion. So we're going to use cross multiplication to solve. So negative 1 times 4p is negative 4p. 4 times 1 makes 4. And then we're going to divide out the negative 4 in order to get p alone. So p is equal to a negative 1. Now, if you're a little more intuitive, you can see that, oh, well, this is a fraction, this is a fraction. So that means this had to make it into a negative 1/4. So that means p must have been a negative 1. That's a perfectly valid way of finding the value of p as well. This is just the more mathematical method. So now that I know that p is a negative 1, and the negative means it opens down, so we're good. The focus is going to be this many away from the vertex. So that means from the vertex, my focus is going to be 1 underneath because it has to be inside the parabola. My focus can't be out here. That's not what the definition of a focus is. So if I move 1 unit down, this is where my focus will end up. And also, the directrix is 1 unit in the other direction. So for the directrix, I'm going to move 1 unit up. So this is where my directrix is, here. And it has to be horizontal because they always have to be perpendicular to the axis of symmetry. So the focus is the easy one because it's a coordinate. So the coordinate for the focus is an x value of negative 2 and a y value of 0. The directrix, being a horizontal line, means it's y equals, and then the y it's at is a positive 2. So we have found all the pieces that was asked of us. Pause the video, see if you can try example number 5. So here's what we have so far. So we have that the layout should have been x equals 1 over 4p times y minus k squared plus h. And since the k is on the inside, when you do your vertex, this is actually h and this is k, but the opposite sign. So we get a vertex of negative 1, negative 5, which is here. Now we need to look at opening direction. So since it is x equals, I know it has to open either left or right. Then we look at the a in the front. So since this is a positive value, that means it has to open to the right. Now, since it opens to the right, your axis of symmetry is now a horizontal line through the vertex. And so it is no longer x equals. Horizontal lines are always y equals, and then it goes through the vertex, so it has a y equals negative 5. Now let's determine the focus and the directrix. So I need to know the value of p. So if I do the mathematical way one more time, so if I take 1 over 16 equal to 1 over 4p, and I use cross multiplication to solve, you get 4p equals 16, divide out the 4, and you end up with a value of 4 for p. So what that means is the focus and the directrix are both 4 away from the vertex. Well, the focus has to be inside the parabola, so the focus is going to be to the right. And so if I count 4 units to the right, so 1, 2, 3, 4 units to the right, this will be my focus. So my focus will have coordinates of a positive 3 and negative 5. When you do the directrix, you're going to go 4 units to the left. We're going outside the parabola this time. So 1, 2, 3, 4 units to the left will be a vertical line at x equals negative 5.